my great pleasure to welcome you to the breakout session on what newcomers should know about dialogue. My name is Milica Gašić, and I lead the Dialogue Systems and Machine Learning group at Heinrich-Heine University, Düsseldorf. So I've spoke to some of the more prominent researchers from our field, and we share similar frustration that we are invited to review papers that seem to reinvent the wheel, and likewise we sometimes sit in talks where there are experimental results about phenomena that have been known in dialogue field for many decades. So while it is great to welcome many newcomers to the field and that the field is really expanding, I think it's really the duty of us who have been here for a while to share what has been here before the big bang, the big deep learning bang. So I will start the discussion around this topic, and there are a few questions that I would like to have some answers. And it is great that we have here not just newcomers, but also those who have been in the field for a while. And I think I would really invite people to share their opinion and experience on this topic. So my first question is, what are the main dialogue concepts that every researcher should know about, and in particular every graduate student? So I can start off just by sharing some ideas. So I think for a long time there was a very strict division in dialogue field between chat-based systems and task-oriented systems. And now with the availability of large corpora and powerful deep learning algorithms, these distinctions seem to be blurred. And maybe in general that's a good trend, but because in human conversation we don't really necessarily make such a distinction. But I think it's important to keep in mind some of the concepts that we still need to model, or that the algorithm still needs to satisfy during the conversation. And in my mind, particularly when we have in mind task-oriented or goal-directed conversation, there are two components which are really essential. And this is the ability to track what has happened in conversation, or the ability to summarize the context, and the ability to plan or to steer the conversation towards a successful fulfillment of the goal. And these are two aspects that really need to be considered when modeling dialogue. And we've seen in some end-to-end approaches that somehow they tend to be solved using supervised learning, which does not necessarily always attack these two issues. And this is really something that has been known in the field for quite a while. So I'll just mention the work by Levin et al., a stochastic model of human-machine interaction for learning dialogue strategies, which was published back in '98. And also work by Roy et al. On spoken dialogue management using probabilistic reasoning, which was published back in 2000. So I see that Michael McTeer has joined as well. I wonder, what are your thoughts on these issues, or any other basic dialogue concepts that seem to not be sufficiently present in nowadays in publications?
Yeah, I think, thank you. I think one of the difficulties, it's easy enough with slot filling dialogues and frame-based, whatever you want to call those. They do perform a task. But once it deviates from that, I mean, for example, if somebody has a clarification question, you know, the system might say, where do you want to go to? And you say, well, what are my choices? Those sort of things seem to break down immediately, really. So I think it's very important for people to have a good understanding of how conversation actually works. You know, talking about dialogue modeling. There's a lot of work done, for example, by the conversational analysts that talks not only about adjacency pairs, but the way you can have insertion sequences and so on, and how the dialogue develops sequentially over time. It's not actually all planned out in advance. It actually develops interactively, really on a turn-by-turn basis. I think there needs to be some awareness of that. I don't really see it in any of the work nowadays. I'll just mute here then so that.
So yeah, just to comment on that, I think indeed, like the research in conversation has a lot more to offer, and I think it's nice that deep learning methods allow us to implicitly model some of the phenomena that we used to have specific models inside dialogue. But it is very important to make sure that they are still there in one form or the other. So, for example, the work on grounding by David Traum, I think it's important for people to be aware of what grounding means, even if it's not specifically explicitly encoded in the model, because it's really the basis of conversation.
Yes, I mean, what you were saying at the beginning about reinventing the wheel. I was reviewing a paper last year for ACL, and it said something like, this is the first attempt to do something on plan recognition. And I had to laugh because if you go back, and David would substantiate this, the work that he did, and Phil Cohen and James Allen and so on, way back in the late 70s and 80s. And this paper had really no idea about any of that work at all.
Yeah. Okay, I see there are some chats, so I'm just gonna call David to join because people who are following this live on YouTube can't see the chats. David, can you maybe repeat what you said?
Sure. Yeah, just I agree with what Michael said, and what you said at the beginning. The key characteristics of dialogue does include, or does require, an ability to model the context in some manner, and also to be able to direct the future. I wouldn't agree, though, that this is a distinguishing aspect of task-oriented dialogue compared to chat. That chat also, good chat dialogue, casual conversation requires both of these as well, and that we can actually, simulate both of them without such a facility, but it ends up being a degenerate form of dialogue. So question answering, is something that happens a lot in dialogue, but it's not dialogue itself just because of that. You want to have some context that's built up, and the way you would address a question would be different if you had just seen only that utterance, or you had seen many utterances before. So if you get the same question, 3 or 4 times in a row, you should stop giving the same answer, most likely. Otherwise, it's not dialogue. And again, referential terms that refer back to previous aspects. So there's a lot of reasons why this kind of context is necessary.
Yeah, absolutely. I mean, it's the fact that it's difficult to define, or that goal is latent, and there are very many goals within chit chat, does not mean that they're not there at all.
And even without explicit goals necessarily, for the conversation to be coherent, you don't want to just say, hey, do you like dogs? What's your favorite movie? You know, I was born in Florida. You know, it's not a coherent conversation, even if each response, each question then has a response. You want to be able to direct it in some way that there's some coherence, and one thing leads with relations to the next, and you can direct the conversation to get to some kind of endpoint, even if it's just that we know each other better and we've had a good experience. So that's again, you may have ill-defined goals or many goals that sometimes conflict with each other, but you still want to have some ability to direct rather than just react to what someone says in order to have a dialogue.
Yes, and I think an important concept that comes along these lines is the initiative, and who takes the initiative in dialogue. Is it the user? Is it the system? And then, of course, we have the concept of engagement, which is particularly important for situated dialogue. We're talking about spoken dialogue in particular. There is the concept of turn-taking, and we somehow assume that we always have user and system talking, but actually there is a lot work on incremental dialogue, and we saw a really good keynote yesterday on that topic. But while I'm at incremental dialogue, I would like to call David Schlangen to join the conversation.
Right.
Because he is the prominent researcher from my first paragraph who actually inspired me to do this discussion. So maybe you can share your view.
Right. Thank you. So sometimes I wonder whether the problem isn't actually a little bit more fundamental even. I mean, it's kind of good that we got the attention of all the machine learners, but the challenge for us now is to get them to be actually interested in the domain. And sometimes for machine learners, it seems to be a matter of pride not to know anything about your data set, right? And to treat any kind of data set as long as you have you know what the why is that you want to predict. You don't really need to care about the structure of the data itself. And to a certain extent, they have been successful in reframing the field, because the chit-chat stuff that many people are working on kind of aims to turn the problem into something that is amenable to these kinds of approaches. I think people are finding now that they're hitting a wall because as a phenomenon, this is too rich to be modeled in this way. I mean, people have discovered recently that you need some sort of coherence over many turns. But maybe the problem actually is more fundamental. Maybe dialogue is a phenomenon that you can't learn from data. It is something that you can only learn from, or not, maybe not only, but an important part of it is learning it from actual interactions. And this kind of sits. This is far away from the usual paradigm. So, in terms of what newcomers would need to know, I think they would need to get an appreciation of the fact that dialogue is a kind of action and not a structured thing that you can learn from the artifact. Yeah.
I think this is a really good point. And actually my student told me, oh, you know, when I first started working on chatbots, I thought, oh, it's such an easy task. You have all this data and you can just train an RNN model and the output seems natural and human-like. But actually, the more I learn about this, the more I realize that there are actually so many difficulties, and I think this is maybe the problem, because it on outside it looks very easy, but actually there is so many things going on in dialogue and so many different NLP problems coming to one, and how do we then model it? How do we evaluate it? Okay, so there was one chat coming from Nigel. Is Nigel there? So because people on YouTube can't see what you're typing, maybe you can just say.
Oh, yeah, sure. So, I mean, you started out by saying, what do we give the students who are starting out in dialogue, or the researchers who are trying to migrate into our field? And Jurafsky and Martin has a decently good chapter on dialogue, and maybe we can just force everybody to read it somehow, or I don't know. And then Gabriel and I did a dialogue technology tutorial interspeech 2015, complete with the bibliography, which is of course out of date. So I mean, there are some researchers out there. I know there's books on dialogue, but you're not happy still. So what do we really need? So are you thinking of a resource? Does somebody need to write a textbook? Do we need, what would solve this problem of ignorance?
Okay, I think this is an excellent question for newcomers. So I'm pretty sure there are some here. At least some of them wrote directly in the chat previously. So would you like to chime in? I can try to find your name if you. So.
I think it's a tough call to ask newcomers what they should know but don't. I guess what did they learn that they wish they had known a few years earlier? Maybe it's the right way to phrase the question. But
I would love to chime in here, actually, if I could.
Yeah, go ahead.
So I'm somewhat of a newcomer in this field still, but I actually came from linguistics. So a lot of the issues you're talking about aren't necessarily a problem for somebody coming from my field. And it was actually kind of shocking to me when I got into this field, how little linguistics some people had studied, more of the machine learning crowd. And so I think it's time to maybe start recruiting more from linguistics, people who are technologically minded. But so I got into this field as an undergrad. I just happened to get an internship at ICT and discovered that I really loved this field and pursued it. But perhaps we should be looking more at people in the field of linguistics or people coming from, other disciplines other than computer science, and trying to get people interested in the computer science so that we have more of a diversity within this field of not just people coming from computer science, but people also coming in from linguistics.
Carla, I have a quick question. When you say this field, do you mean this dialogue, the SIGDIAL, or do you mean more general natural language processing?
More general natural language, okay. Yeah.
See, that was a dialogue.
Yes, that's true.
Clarification.
I mean, certainly modeling dialogue can be seen from many different perspectives, and there are a lot of things that one need to know, not just from the linguistics, but also from other fields. I think also when people talk about machine learning, usually they think only about deep learning, but there are also many other machine learning methods which are potentially very useful for dialogue. So having a broader knowledge, I think, is certainly helpful. Okay, I would like then to move to the next point, which is how do we evaluate our dialogue models? And I think this point is mainly here because a lot of times when I get to review papers, I see that blue score is very widely used. And I think we would all agree here that it is not a good measure to use, that it can be deceptive, and there are actually works but by Amanda Stant which show that they can be deceptive. So what do you consider a good evaluation measure, and how to how to evaluate dialogue systems. So I can say from my part that I think if we are building user-centric technology, we have to eventually evaluate it with users. And this idea of having user in the loop for both evaluation and potentially learning is very important. And I wonder what others think regarding this.
I think one of the problems there is that user evaluations can be very diverse, particularly if you're looking at something more like chit-chat dialogues, where there isn't a specific goal that you can evaluate against. If you're wanting to say that was a good conversation, people have found, I mean, in the Alexa Prize competition, for example, people found that the sort of responses and judgments that users gave were pretty much unreliable and, well, as I say, very diverse. Some thought that was a great conversation, others thought it was hopeless, and so on. So I think that's one of the problems. Yeah, I'll stop there.
I mean, if we think about task-oriented dialogue, what was at least very common in this field is to report successful completion and whether dialogue is successful. But then if we think about other metrics that we can use, of course, the more we think about various, it can be more and more difficult. So for instance, measuring naturalness, or if we talk about generation, measuring adequacy, fluency, readability, or variation. So these are, I think, important measures at least to have heard of, even if setting up a complete human trial is difficult. But I have to say that nowadays, with availability of crowdsourcing, this is to a certain extent easier. I mean, you don't have to recruit volunteers and get them into your lab to test. Though I suppose if you want to test dialogue, which is for robots, you still need to do that. I don't know, Gabriel, do you have any view on this point from your experience?
Sorry, could you repeat the question? I was reading the chat. So.
Talking about evaluation and what are good metrics. And I mean, we can utilize crowdsourcing to a great extent for chit-chat dialogues and task-oriented dialogues, but what about embodied dialogues and spoken dialogues, and how do you?
No, that's of course very costly. I don't have a good answer to your question. It just is very costly if you want to do more embodied or situated interaction. And as you say, even spoken, I guess you can do some kind of spoken interaction with crowd workers, but if you're interested in things like turn taking and more fluid interaction, of course, it's sort of technically more challenging to set that up, I guess. So yeah.
But I'm also thinking, so for instance, if we think about, okay, we can model dialogue using reinforcement learning, and then we can use this objective of reward as an evaluation measure. Is there something similar for other concepts that we need to model? Like, so what kind of offline testing can you do with an interactive dialogue that is doing incremental interaction, for example? Is there?
I mean, I don't know. You can of course set up user simulations and so on, but I've always been a bit skeptical to what you actually learn from that. And I think maybe we should, to a larger extent, sort of connect academics with industry, because that's where you can actually, once we've had a chance to set up, for example, Forhat in public space or somewhere, that's where you can actually evaluate your system with hundreds of users suddenly. So I think there is actually a need there, of course, of new models and thinking and so on. So yeah, I guess these kind of test beds is what you really need, because I really think we have to evaluate with real users in the end.
I think Let's Go was a great example of that, where they could actually not just give us humans, but actually real users, and that was really something that I think changed, or at least when I think about big events in the field, that was really great. And also, of course, more recently, the Alexa challenge, which have already been mentioned. Okay, so is there anybody from industry maybe who wants to say something on collaboration with academia and contributing to, just having a quick look through the attendees. If anyone wants to shine in. No? Okay, just okay, maybe just reading some of the posts. Andre Dushek, are you there? You posted something on how you think we can.
Yeah, I was just commenting on Emer. Is that how you pronounce the name? Who suggested that we should probably update this this interspeech tutorial with new bibliography. So I think it would be nice to have some kind of a wiki or some kind of a resource that we could all collaboratively keep updated, that would be helpful for newcomers.
Yeah, I think that's a great idea of having a wiki. I think in the field, in mathematics, there is a page where they have all open problems, and I think I mean, of course, mathematics is such a big and long term, but it would be great to have something like that for dialogue. So what? I mean, of course, it's difficult for us to quantify exactly where we are at each point, because it's not so clear cut, I suppose. But at least have a page with problems and yes, current state of the art, and maybe it's, of course, new publications are coming every day. But I think there are some important publications that will still be important in years to come. So I was trying to pick my sort of top 10 papers that I think, so this is pre-2010, that I think every first-year graduate student should read. So if we talk about evaluation, I would of course mention Walker Paradise from 97. Then I think one thing that I think is very important, and I always encourage my students to read, is the notion of dialogue acts. And for that, I think the paper by Poesio and Traum towards an axiomatization of dialogue acts in '98 is particularly important. But does anybody have any paper that they would like to single out? I mean, it's not so important that it's mainly to bring something in that maybe is often overlooked.
Could I? Sorry. I'm Imogen Martin from Dublin, and I was in a like Carl, I was in a position about 5 or 10 years ago where nobody in Dublin was doing dialogue. And the thing I found most useful was to get the reading lists from the various courses that are being held for first year postgrads or undergrads. For example, I really benefited from David Traum's course list, the readings which were available. And also from Alan Black had one at the time as well, which again went right back into the dialogue theory as well as the more state-of-the-art implementation work. Because as you said, I think what's happening now is people are getting a chat kit of some description. They think dialogue is chat, and they never go back to, because they quite rightly look for recent references rather than something from 2004 or 97, which is what they really need, So just wanted to comment on that. So I don't know if anybody in the group is currently giving a course on dialogue systems, and do they have their book lists, etc., available?
Andre, I suppose you are giving a dialogue course.
Yes. I must say I agree with Emer that those reading lists are very helpful. And I've actually, while preparing my course, I've been using some of these as well on all the old websites of those courses. And yeah, I would say that the reading list for my course is mostly textbooks, and I don't think there is like one ideal one. I remember somebody mentioned that this Jurafsky-Martin chapter, which is basically like the number one on my reading list, and then a few textbooks. But I guess I should probably also refer my students to the papers, which I'm currently not doing, and I guess this is not ideal.
I think it was last year. I was reviewing a paper for a very prominent venue, and the paper did not only mentioned works from 1 year. Basically, it was all within the last year, and it was dealing with the concept that has been there from the beginning of the research in dialogue. So it wasn't really. So I think this is something that we really should try to some way prevent, and it's really the research did not start with the deep learning boom. That there was a lot of work on various topics before.
Luca, can I chime in on that? Part of that's the reviewing process. I've come up against reviewers in these prominent venues where the reviewers are very new at dialogue, and they don't want you to cite anything that's earlier than 2 or 3 years because they figure that's too old. And the dialogue models are the deep learning models. I mean, language is solved with BERT, and that's kind of the complaint. I can take the opposite stance and say, well, no, a lot of these problems have been considered in the SIGDIAL community for decades, and you should not ignore those. So part of that's the reviewing process, and part of that's just good scientific rigor. And I don't know how much I don't know what it means for us to do that, other than when we are reviewers, that we make sure to inform our fellow reviewers and the authors that this field does exist, and that people have solved these problems a long time ago.
Yeah, and of course this is exacerbated by archive where papers are put that are not even reviewed. So I think.
Let me just point out that this is not a new problem. It may be relatively new for our specific subfield of dialogue, but I remember when I was a grad student, many years ago, that people would get up at ACL and say, "You're ignoring this work that I did 10 years ago, and that states this problem." And so I think it is something that won't just be solved by a reading list. And I guess another observation from my course, less than 2 years ago, that I tried to have a mix of relatively recent work and some of the classic work that people are referring to here. And one of the pieces of negative feedback I got from the students was there was too much older stuff. Now I thought it was important because it's not just the solutions, which in some areas you have better solutions now than you did, not in all yet. But even the definition of the problems, what are the problems with dialogue that are worth solving? some people write papers that claim to have come up with new problems, and that's certainly not the case when the same observations and issues have been made, and even solutions in some cases. So I think we need, I mean, it's definitely a first step to make it more clear what we think, what are the cream of the papers from many years ago that are extremely helpful and still relevant. But I think we need to think of a better way to focus that or gain the interest of the new researchers.
Yeah. There's a marketing aspect of it that some, like conversational user interfaces, that's a fairly new venue, but it's basically trying to solve the same problems that the dialogue systems community has been working on a more, usually in the realm of chatbots from what I've seen so far, but marketing, I think, and that might be something that, I don't know, the SIGDIAL board or something has somebody join the board or part of the SIGDIAL leadership that helps with marketing. I know that there's people who are in charge of the social media accounts, but maybe a little bit more, I guess, like paper highlights from SIGDIAL, those kinds of things could be really helpful to help gain publicity.
Absolutely. I think I just want to come back to what David said about it's about the problems and not necessarily the solutions. And this is something that I'm always have at the back of my mind when I review papers, like how creative actually it is rather than what is the exact outcome that it achieves. With that in mind, when I was preparing for this discussion, I was thinking about what are the data sets that are out there and what do they offer to somebody who is joining this field. And I think one data set that is worth mentioning, for example, is ATIS, which is very small and simple. It's very important to have heard about this data set, but do not report your results on this data set because it's too simple to model dialogue. And of course, I already mentioned Let's Go data and how important that is because it has real users. But there are other phenomena like robustness, which is shown in the STC2 data set. Large dialogue corpus multivoice, but then also very large corpora like Ubuntu, which is not labeled at all, and of course the most recent Alexa data set. And I think it's important for people to know about these, but also in a similar way about toolkits. And also, so for instance, I don't know how many graduate students now have heard of Jupyter, for example, from MIT in 2000, which of course is now suppressed with more recent toolkits, but I think from an engineering point of view, it's important to know how you actually make a spoken dialogue system, how you incorporate speech into dialogue system. I wonder whether people who have been developing full systems, like spoken systems or multimodal systems, have anything to add on this. David, I'm looking at you, but you don't see that I'm looking at you.
I missed a part of the trend. So you're asking about toolkits for multimodal, or
Yes.
was there a specific slant to the question?
Yes, yeah.
I mean, so we do have a virtual human toolkit at ICT that includes some language aspects as well as virtual embodiment and ability to do animation or build semantic rules that can govern kinds of animation and gestures. But we don't have we've used, I mean, the dialogue manager we include is well set up for creating your own question answering characters without a lot of dialogue modeling. There is an ability to build your own more sophisticated one in there, or use a different piece of software from the NLU and NLG that you use. But you know, there's still a lot that people need to do themselves to do something that's very different from question answering.
Yeah, I think what's important to note is that now with the, I mean, with this deep learning boom, what happened was that we have these toolkits that that everybody can use. I mean, of course, before, at least when I joined this community, the privilege of working on a spoken dialogue system was just the privilege of a few. And nowadays you can just go on GitHub and get newest ComLab or newest PyDial, and you can start. And I think that's great. But maybe we do need really to complement this with more theory. And I just want to add a few more publications which David mentioned. So Dialogue by Raquel Fernandez, Modeling Dialogue Challenges Approaches by David Schlangen. So, okay, I think we have 5 minutes left. So maybe some of the newcomers would like to ask a question to any of the attendees. Don't be shy. Can go through the...
Hi, so this is Vishal. I had a question. So earlier, one of you mentioned features, phenomena in dialogue like grounding and other aspects that comes in from the discourse theory of dialogue, which are kind of ignored in recent models. So can those things be used for evaluation? And if so, how can we have a scalable approach for this? Because when you are going for human evaluation, it's very difficult, as you mentioned earlier, because we have to think about the number of questions that we might want to ask, and that should be easier for the annotators to answer. These sort of problems come up, right?
Sorry, I missed the beginning of your question, so I couldn't, if you can just repeat the beginning.
Yeah, sure. So what I'm asking is like the things like grounding, adjacency pairs that are there from the discourse theory for dialogues, like how dialogue happens in a human-human conversation. So can those aspects be used for evaluation of recent dialogue models? And if so, what would be a scalable approach for this? Because when you think about human evaluation, they are very difficult and costly, because you have to think about what questions you want to ask, and you also have to think about the questions should be easier for the annotators to answer, because if it is too difficult, then it will be very noisy and the annotator agreement will go down. So what are your suggestions?
That is a very good question, and I don't think there is a good answer to that question, because it really points how difficult this area is. I suppose if you model something like, if you want to measure something like grounding, you need to look at, you would need to have some kind of human evaluation. Of course, the definition of a dialogue state can, to some extent, help you in that. So if you can adequately predict what is being talked about at every point in dialogue, yeah, a quick answer to that question is that it is certainly not straightforward to do.
I'd like to add something. Thanks. I'd like to add something about that. We've been doing, or we recently did some evaluation work at ICT in the Internet of Things domain, and one of our researchers, Kalaroy Georgila, used reinforcement learning to create evaluation functions. So first we started with a richly human annotated data set, and then she learned evaluation functions based on that data set that were able to predict human scores. So that is one way to scale human evaluation, is to use human evaluation to create evaluation metrics.
Yeah, certainly. I mean, that is a good idea. If you have data set from where to begin, then It's really a good idea. Oh yes, there is just one more thing, like terminology glossary. So maybe that's just enough to say in a minute. I think, Casey, did you mention this? Where are you?
I'm here. Yes. So people say dialogue. What does that mean? People say chatbot. What does that mean? How are they related to each other? I hear the word grounding a lot, but it's conversational grounding a la Clark is different from, for example, language semantic grounding, for example, into visual modalities like Harnad. So it would be helpful, I think, to have a glossary along with whatever bibliography resource that we come up with.
And also common ground. Sorry, common ground. It was very
ground, right. That's the Clark stuff.
Communicative grounding, common ground, and then the grounding with the images. Communicative grounding. Yes.
Yeah, but then there's Matthew Stone's stuff on societal grounding as well, and then there's Stefan Larsson's stuff that kind of teases this apart. That's just about grounding. There's plenty of other terms that we would need to clarify for the field, I think, for anyone jumping into the field, and maybe point to some papers of like, these are the papers you need to know about if you want to go down this path, and whatever term they happen to choose.
Yeah, I mean, in the same way, I think new things, the same things get reinvented and then labeled differently. I've seen a lot usage of word response generation when they actually mean action in policy, and we use generation for one thing and policy for another thing, or dialogue strategy. So I think that is something really useful for the community. Okay, I think our time is up. I think there are a lot of potential things that, we probably opened more topics than we actually answered questions. But I think there have been a lot of good ideas how we can proceed. So I'd like to thank you all, and hope we will build a more informed community that will continue to publish such great research. Thank you very much.
Thank you.
Thanks very much. Yeah, bye.
Yeah. Okay. Yeah, I wonder whether some of these things could go on the website of SIGDIAL.
Yes. So that we can make that work. We can move kind of this discussion to Trello so it's a little bit more open, because we're going to keep this live stream on for the next session that starts in a little bit. But we should definitely email and talk about what kinds of resources we should come up with.
Yeah.
And we can think about this for the next day, and there may be some concrete proposals that we make for the business meeting tomorrow.
Okay.
So I'll email you. I'll give you the chat,
Okay.
the chat history that came out of this discussion, and then of course this live stream will be live for anyone to watch on YouTube later if they want to.
Okay.
So, yeah.
Okay. Well, thank you. I think that worked well.
I do too. I'm glad you did that. It was very great.
Okay. Well, see you later then.
See you.
Bye.
Hello, I'm here today to talk about unsupervised evaluation of interactive dialogue with Dialogue GPT. My name is Shakib Mehri, and this work was done at CMU with my advisor, Maxine Eskenazi. Evaluation methodologies shape the direction of research. They're used to compare between systems, which determines what gets published, and they're used to identify the weaknesses of systems, which determines what the research community works on. However, for dialogue, our current evaluation methodology has certain flaws. Dialogue is meant to be inherently interactive. Dialogue systems are designed to have a back and forth interaction with the real user. However, to date, research has largely focused on static corpora, and this reduces the problem of dialogue to that of response generation. Unfortunately, with a static data set, some properties of dialogue systems can't be effectively assessed, and for certain properties, you need an interactive environment to really assess them. This includes things like long-term planning, error recovery, and coherence. Furthermore, dialogue quality is multifaceted. A response isn't just good or bad, and you can't reduce the complex idea of dialogue quality to a single number. Especially for the purposes of interpretability, we should be measuring multiple different qualities of dialogue, including things like relevance, consistency, and fluency. So evaluation is important because it shapes the research direction of a field. We should be evaluating dialogue in an interactive manner, and we should be assessing several different aspects of dialogue quality. And one thing that I really want to emphasize here is that the only perfect evaluation mechanism is human evaluation. If you have a dialogue system and you really want to get a sense of its quality, you should be performing human evaluation. But human evaluation is both time-consuming and costly. And as such, there are certain scenarios where human evaluation is not feasible. This includes things like during development. For example, if we're doing hyperparameter tuning, it's infeasible to be consistently running human evaluation. For large-scale analysis, like if we want to identify erroneous dialogues, we need an automatic metric. In this paper, we present fine-grained evaluation of dialogue. We first take a collection of interactive dialogues released by Ariwardana et al. This includes dialogues between humans and Mina, humans and Mitsuku, and humans. We annotate these interactive dialogues for 18 different dialogue qualities, which is called the fed dataset. We then present an evaluation metric that captures these 18 different dialogue qualities, and we call this the fed metric. Here's a list of all the dialogue qualities that we capture. At the turn level, we capture things like interesting, engaging, relevant, fluently written, and at the dialogue level, there's qualities like coherence, consistency, diversity, the adaptability of the system, whether it's inquisitive. And to create the set of qualities, what we did was we looked at the literature and we looked at the metrics and the qualities that people used to assess their systems. We tried to collect as many different qualities as possible so that we have a wide range of qualities and a diverse set of qualities. So we took interactive dialogues and we annotated 124 different dialogues. For each dialogue, we asked 3 turn-level questionnaires. So basically, we assessed 3 different turns. And given that there's 9 turn-level qualities, this gave us a little bit over 3,000 turn-level data points. We also asked 1 dialogue-level questionnaire. And given that there are 11 dialogue-level qualities, this gave us 1,300 data points at the dialogue level. Everything was annotated by 5 different annotators. To give a sense of the results, at the turn level, we see that Mina outperforms humans, and then humans and Mitsuku are roughly at the same level. And what this suggests is that at least for the task of generating responses, Mina has surpassed humans' ability through large-scale pre-training. Because we collect several different fine-grained qualities at the turn level, and then also ask for an overall impression, we can determine which fine-grained qualities most contribute to the overall impression. And what we find is that for our annotators, interesting, relevance, and fluency contributes most to their overall impression at the turn level. At the dialogue level, we see that humans outperform Mina and Mina outperforms Mitsuko. And this result really highlights the importance of assessing systems in an interactive environment. If we were just looking at the static task of response generation, we would think that Mina has surpassed humans. But now looking at an interactive dialogue where the system has to have a back and forth interaction, we see that humans still outperform Mina and Mitsuko. At the dialogue level, the qualities that contribute most to the overall impression are coherence, likable, which includes things like personality and empathy, and also whether the system understands the user. So how do we go about developing a metric? First of all, there's no training data because the fed data set is a set of human judgments that we use to assess our metric by correlating it with human judgments. So no training data. We don't have a reference response because this is an interactive setting. And we need to capture 18 different dialogue qualities. To explain how we go about developing the fed metric, there's two pieces of prior work that I want to discuss. In 2019, as part of Eskenazi et al., we did some work where we found that the next user utterance is especially important for evaluating dialogue systems. For example, if the user says, "How are you today? I was just watching the football game," and the system responds with, "Did you know cats sleep for 18 hours a day?" then the user responds with, "Huh? That's not relevant at all." By looking at the user utterance that's following the system response, we can get a sense of how good the system response was. And as part of Eskenazi et al., we did this for task-oriented dialogues, and we found that often, by looking at the next user response, we could better evaluate, both in terms of annotation and in terms of modeling, how good the last system response was. But in open domain dialogue, what are the odds that the user says something useful in their next response? For open domain dialogue, if we just rely on the user calling out a mistake of the system, we might only capture the worst of the worst system responses. The next piece of prior work is that large pre-trained language models, such as BERT, have been shown to implicitly capture world knowledge. In Levesque et al., they showed that BERT captures some notion of common sense. Dialogue GPT has claimed human-level response generation capability, and given the results that we saw from our annotation of Mina's conversations, this might very well be true. So now the hypothesis here is that Dialogue GPT has implicitly captured some notion of dialogue quality in the process of learning how to generate good responses. And now linking together the first piece of prior work in Eskenazi et al. With this idea of Dialogue GPT capturing some notion of dialogue quality, we think that we might be able to use Dialogue GPT in place of the next human utterance. And this is the fed metric. So given the dialogue history, which includes the response that we want to evaluate, we compute the likelihood using Dialogue GPT of generating a positive follow-up utterance versus a negative follow-up utterance. So for example, if the system said that, "Did you know cats sleep for 18 hours a day?" we compute the likelihood of Dialogue GPT in the place of the user generating "cool, very relevant," versus "that's not relevant." And the idea here is that because Dialogue GPT has attained human-level response generation capability, it knows that it should generate the positive utterance in a situation where the last system response was relevant, and it should generate the negative follow-up utterance in a situation where the last system response was irrelevant. We take the difference of the positive score versus the negative score, and this tells us how relevant the last system response was. So for the fed metric, we write a set of positive and negative follow-up utterances for each one of the 18 different dialogue qualities. For example, for interesting, one of our positive utterances is, "Wow, that's so interesting." And one of our negative utterances is, "That's really boring." And the model, Dialogue GPT, because it's so good at generating responses, should know that one of these responses is better to generate when the last system response was interesting, and another one is better to generate when the last system response was not interesting. To compute the overall impression of both the turn level and the dialogue level, we take the average of all the fine-grained scores. we evaluate 4 different variations of the dialogue GPT model, both medium and large models, and models that were fine-tuned from GPT-2 or trained from scratch. For the turn level qualities, we attain correlations between 0.11 and 0.43. The highest correlations are for qualities like interesting, engaging, and specific. Our overall turn level correlation is 0.21. For dialogue level, we see correlations between 0.25 and 0.52. The highest correlations are for topic depth, diversity, and informativeness. And the overall dialogue level quality is 0.44. And while there's still a lot of room for improvement here, I think that these results are still fairly impressive because they were done without training data and without any fine-tuning on in-domain conversations. Really what this shows is that Dialogue GPT has in fact implicitly captured some notion of quality, and that by using the strategy with the follow-up utterances, we are able to extract out some of this idea of dialogue quality. To summarize the contributions of this paper, we developed FED, which is an unsupervised fine-grained evaluation metric that measures multiple fine-grained qualities of dialogue, exhibits strong correlation with human judgments, and because it relies on no training data and only requires follow-up utterances, it can easily be scaled up to other dialogue qualities. We released the FED dataset to facilitate the development and assessment of new evaluation metrics. We also open sourced the code for FED, and it's honestly really easy to use. Really all you need to do is you load in the model, you specify the conversation, and you get back a dictionary that consists of all of the dialogue qualities. Thank you.
Hello, everyone, and welcome. My name is Sarah Finch, and I'm a PhD student at Emory University. Today, I'll be presenting our work on exploring the common evaluation procedures that are used for current chat-oriented dialogue systems. So there's a pretty widely accepted distinction in dialogue systems between those that are task-oriented and those that are open domain or chat-oriented. Traditionally, task-oriented dialogue systems carry out a conversation with a user in order to accomplish a specific goal. Because of this, there are some pretty obvious ways of measuring how successful a dialogue system is. You can pretty much just look at how accurately and efficiently the system is able to complete the task with the users. However, there's not such an obvious measurement for chat-oriented systems. Since the goal of a chat-oriented system is much less defined, and the aim is more to be an engaging and entertaining social companion, this is often difficult to reduce to specific observable outcomes. It becomes quickly apparent when reading current dialogue system works that there's actually a wide variety of evaluations being performed, which makes it difficult to compare different chat-oriented dialogue systems with one another, and even to identify what the best approach would be for evaluating a new one. Our goal in this work was to use the recent rapid growth in chat-oriented systems in order to identify which evaluation methods have been the most widely adopted by the community and to analyze the extent of variability within these methods. So in order to address our first goal of identifying the common evaluations, we selected 20 different papers that have been published within the last couple of years, making sure to select papers that have a lot of diversity in the actual chosen approaches. So from these 20 papers, we saw that both automated and human-driven evaluation protocols are frequently used, almost evenly across the board. And actually, many papers even use more than one of the evaluation types. So I first will briefly cover our observations on the use of automated metrics. The reason for this brevity is that looking into the automated metrics wasn't a main focus of our work, since there's already been kind of substantial effort into analyzing automated dialogue evaluation. But for our work, what we found is displayed here in this table. Essentially, this table shows which automated metrics have been used in the 20 papers and what papers specifically they were used in. So in total, we found 11 different automated metrics, where a handful of them are used somewhat widely across the papers, such as the blue score being used in 14 of them. In general, from looking at the different automated metrics, the automated metrics that are used tend to be explained as measuring either the ground truth response similarity, the context coherence of the system responses, and the overall response diversity. So although some analysis work has been done for automated dialogue system evaluation, the same is not as true for human evaluation methods. So we specifically focus on human evaluations in this current work. And I'll now move on to our observations there. For human evaluations, we saw two primary types being used, static and interactive, with static being much more common. A static evaluation generally involves generating a system response to a given dialogue context, and then having humans look at the dialogue context and the given response and rate the response on some specified dimensions. On the other hand, interactive evaluation has a human both actually interact with and have a conversation with the system, and then finally at the end of the interaction, rate the conversation on some specified dimensions. Within both types of human evaluations, the actual rating methodology had some variation too. Mostly, it was the case that numerical ratings were requested from the human, but a small number of works used preference selection instead, where the human selected which option from some set of options was better than the others instead of providing an actual explicit number. So one thing that all of these human evaluations shared in common was that the evaluation was done with respect to some specified characteristics of the conversations. When the evaluators were asked to provide a rating or even to pick the best option, it was phrased in the context of some dialogue dimension, like how relevant the response was or which response was the most human-like. So similar to what we did for the automated metrics, we also looked at the spread of dialogue dimensions across works. So this table shows the dialogue dimensions that were used and what paper they were used in. In total, we found 21 dialogue dimensions that were used. As you can see, there's pretty large sparsity present in this table where only few works use the same dialogue dimensions as others in their evaluations. And actually, there's really only one dimension that we saw, which is fluency, that was used on kind of a widespread basis. And even then, it was only used in 9 of the papers. So this kind of sparsity led us to look into the actual dialogue dimensions a little bit more. And on an intuitive basis, we noticed that a lot of the dialogue dimensions seem to be potentially synonyms or very similar to one another. And if this was actually true, that would mean that there's a lot more overlap in the human evaluations of these papers than it may at first seem. So in order to explore this idea more, we collected the definitions provided by each of the papers of their dialogue dimensions and tried to assess whether or not these definitions provided support for the merging of certain dialogue dimensions together. So to illustrate this process, let's take a look at an example. On this slide, you can see a table which provides the definitions that we could find for 4 dimensions across 7 papers, where the 4 dimensions are fluency, consistency, readability, and grammaticality. On the right-hand side, you can see the definition that each of the papers provided for those dimensions. And from looking at these definitions, you can see that each definition focuses on the same idea. They focus on the idea of the system's responses being fluent, understandable, and grammatical. And so due to this kind of high definitional overlap, we thought that there was sufficient evidence for treating these 4 dimensions as the same thing, namely as measuring the grammaticality of a system response. We followed a similar procedure for the rest of the 21 dialogue dimensions that we observed in the papers, and we ended up finding 5 different dimension groupings that spanned 17 of those dialogue dimensions, which can be seen here. So these 5 groupings basically resulted in dimensions of grammaticality, relevance, informativeness, emotional understanding, and overall quality as main dimensions that previous works have used. However, we also saw that there were 4 dialogue dimensions that did not share any definition overlap with any other dimensions from the papers. One of these kind of unique dialogue dimensions was actually very approach specific, so we discarded it for the purposes of this work. But the remaining 3 unique dialogue dimensions were engagingness, consistency, and proactivity. So based on our analysis, we ended up with 8 dialogue dimensions that can reasonably be applied to any dialogue system regardless of approach type. The 8 dimensions that we ended up with can be seen here, and the top half of this table shows those that were derived by grouping across papers, which are grammaticality, relevance, informativeness, emotional understanding, and quality, and then the bottom half shows those that ended up being kind of unique across papers, which were engagingness, consistency, and proactivity. So given this derived set of dialogue dimensions, we wanted to assess the relationship of the dimensions to one another. Specifically, we were interested in how each dimension related to the overall quality perception of the user. So we used 100 rated conversations from the Alexa Prize, which is a competition held by Amazon, where university teams compete to build kind of the most engaging social bot for human users. And from the Alexa Prize setup, we were able to collect a data set of real conversations that were actually interactively rated by the users at the end, giving a score from 1 to 5 on the user's overall impression of the conversation that they just had. So this type of a rating fits the description of the overall quality dialogue dimension. However, the other 7 dimensions that we previously discussed are absent from this data set. So to remedy this, we also did an expert analysis on the same conversations, where we manually rated the conversations on each of the dialogue dimensions previously discussed, including giving an overall quality rating. So the main goal of this case study was to provide a preliminary understanding of the importance of different dialogue dimensions to overall human perception of dialogue quality. However, I do want to point out that due to the low agreement between the expert overall quality rating and the user's overall quality rating, it is difficult to draw any conclusive results from our case study, but we do hope that this work further encourages additional exploration in this area. So in terms of results, what we found is that relevance and proactivity, which are shown on as the 2 graphs on the left-hand side of this slide, actually display kind of the strongest positive relationship with the overall quality rating. And this suggests that a dialogue system that's able to produce relevant responses that drive the conversation forward in an active way is quite desirable for the overall kind of satisfaction with the dialogue. We also found that informativeness and engagingness have a positive relationship with overall quality, although it's not quite as strong, and those 2 graphs are shown here on the right-hand side of the screen. So this suggests that the amount of interesting and non-repetitive content in the system's responses is also important, although potentially not as strongly correlated as the relevance and proactivity. The relationship between the emotional understanding and consistency to overall quality was unclear from our results, which was somewhat expected since the dialogue system that we used in this case study had little variation on these dimensions. Perhaps the most interesting result that we observed was the negative relationship between grammaticality and overall quality, although it was a very slight negative relationship. One possible explanation for this is that the overall kind of grammatical responses of the overall grammaticality of the responses of our dialogue system was very high in general. Most of the responses were indeed grammatical, and there were only kind of infrequent small mistakes in grammaticality. And so this type of distribution does not really reduce the overall good experience within the conversation, even when the small mistakes are encountered. So that brings us to the end of this talk, where we have presented an analysis of current evaluation protocols for chat-oriented dialogue systems. So to highlight the main points, we found that there are 3 primary types: automated, static human, and interactive human. And we observed that across recent human evaluations, there seem to be 8 dialogue dimensions that are commonly used and commonly applicable. Of these 8, we found that relevance, proactivity, informativeness, and engagingness seem to have the strongest positive correlation with overall quality of dialogues, although this is only a preliminary observation and something we plan to explore more in future large-scale user studies. So with that, we're at the conclusion of this talk, and I would like to thank you for listening.
Hi everyone, my name is Ritika Gupta. I am a PhD student at University of Illinois, Chicago. Today I'll be talking about the work done by me and my colleagues towards building a virtual assistant health coach. In today's presentation, I'll be talking about the data collection, the annotation schemas that we built, and then the analysis that followed. Physical inactivity is a serious problem, and it has only increased over the past decade. It is a primary reason for many chronic diseases such as diabetes and depression. Almost half of the US population suffers from at least one chronic disease. Some of the reasons for less physical activity are, for example, taking transportation for short distances, having a less active occupation, or even the current situation with pandemic where it's harder to get some of the physical activity done. However, one of the underlying reason is actually the lack of motivation. Health coaching has been found to be one of the solutions that works, where a health coach advises a patient to do activity which aligns with their current lifestyle as well as what's going in the world. So they would be suggesting goals based upon the pandemic right now and as well as the occupation they have, so that they can have some realistic goals and achieve them even with everything going on in the world. However, health coaching is expensive and is time intensive, and also people lose interest with time. It's also not available 24/7. So what we propose is we want to build a dialogue-based virtual assistant health coach that can communicate with the patients and help them to set SMART goals, where SMART goals is an acronym for specific, measurable, attainable, realistic, and time-bound. So SMART goal setting criteria helps the patient to set goals that are more specific. An example is shown here where a patient decides to do a walk on my lunch break for 20 minutes, Wednesday and Thursday this week. And it is much more likely to lead to success as compared to a goal which is I'll try to walk more this week. So in this paper, our contributions are as follows. We discussed the data collection methodology for health coaching dialogues via text messages. We discussed 2 rounds of data collection, dataset 1 and dataset 2. We formalized the SMART goal setting approach I discussed in the previous slide using 2 annotation schemas. We showed that the models built on dataset 1 can be used to reliably annotate dataset 2 for at least one of these annotation schemas. And finally, we released the dataset 2 to the community. For dataset 1, we recruited 28 patients from our university internal medicine clinic. We also recruited a health coach who was trained in SMART goal setting. This health coach communicated with the patients for 4 weeks each, and for each week they set a new goal. Fitbits were also given to the patients to track their progress. Patients used their cell phones and then the messaging service to communicate with the coaches. On the other hand, the coaches used a web-based application called MyTap, which was developed by one of our collaborators. The benefit of using MyTap over a normal text messaging service was that the coaches were able to access both the text data and the Fitbit data over this interface. So the coaches didn't have to log into individual patients' account of Fitbit and see how much activity they have done so far. Using this, we were able to collect about 3,000 messages in total. And among these, both patient and coaches almost had equal contribution. Here is an example conversation between the coach and a patient. Here, initially, the patient sets a goal of a 130 flights. However, due to a barrier, they want to modify their goal and negotiate. And then they negotiates with the coach and then finally agrees upon 85 flights. So here we can see that there are these SMART goal attributes, which is the flights or like sometimes what days they're going to do it and such. But then there is also this high level conversation flow where there's initial goal setting, then there's this barrier, and then the negotiation and such. So based on these 2 things, we decided to annotate the data for 2 types of things. One was SMART goal annotations, which was like the slots and values. And the other is this high level conversation flow, which is captured by stages and phases annotation. So for SMART goal annotation, we annotated the data with specificity, measurability, attainability, and realism. We did not annotate for timeliness because each week we set a new goal, and that's where the timeliness was 1 week by default. So for specificity, we try to annotate activity, location, and time. Under measurability, we try to annotate what days they're going to do the activity, how much are they going to do, or how much distance are they going to do. And then finally, the attainability score captures how sure a patient is towards the goal that has been agreed upon. And if it's lower, then coach tries to modify the goal for the patient and discuss that probably they should be changing their goal if they're not so sure. And lastly, the realism is based upon the patient's previous performance. So for example, if a patient did 1,000 steps a day previous week, and now they want to set a goal of 4,000 steps a day, then it's probably not realistic, and that's when the coach intervenes and tells them probably they need to change the goal. Here is an example annotated with smart tags, where we can see that the patient decides to do stairs twice a week on Thursdays and Tuesdays between 6:45 to 7. We also annotated the questions with the intent to see what's the intent behind that question. So for example, in the first one, the intent is they're asking for the days, and then the next they're asking for the time and such. And then lastly, the attainability score, where the patient says they're completely sure and they're rated to be 10. Here we show the distribution of smart tags. We can see activity and quantity are much more common as compared to like time, location, and repetition. Days is also much more common as compared to others. So we see there is a lot of variation in the number or the frequency of each of these tags. Next, we annotate stages and phases. Here there are two stages: goal setting and goal implementation. Goal setting stage is the one where the coaches and the patients communicate to agree upon a goal. And then finally, when the patient starts to work towards that goal, that's when the goal implementation stage starts. There can still be negotiation under that stage. Then below that, there are the phases. The difference between the phases under the goal setting and implementation is, under goal setting, there is only under goal setting, goal identification is there. However, that's not present under goal implementation stage. Similarly, follow-up is present under goal implementation stage. However, there won't be any follow-up under goal setting. Other phases are same. Here is an example annotated with phases and stages. So initially here, the patient says that they want to set a goal of 12,000 steps a day. However, last week, they only did 3 days out of 7 where they were able to accomplish 12,000 steps. So coach brings that up and then asks the patients to modify the goal. And then they finally modify the goal to be 12,000 steps, Tuesday, Wednesday, and Thursday. And then finally, once the goal is decided, they start working towards it. And during the follow-up, during the goal implementation stage, there can always be more negotiation depending upon the circumstances or the barriers the patient might face. Here's the distribution for stages and phases. We can see that goal setting stage has much more frequency for different phases as compared to goal implementation, under which only follow-up phase is more frequent. These numbers are not the number of messages, but the boundary cases. So when a phase shifts from one to another, that's counted as one. And then there can be any number of messages under that phase. And here we show how many smart tags are there under each phase. So we see that identification, refining, and follow-up has most of the smart tags. The negotiation also has most of the measurability tags. And then anticipate barrier is the one where we see most of the attainability tags, where they ask how sure they are between 1 to 10. So now I talk about the development that we have done on this data so far, and then the annotations as well. This is not the part of this paper. We have implemented and published it under 2 different publications. Please feel free to check them out. Here, this is just to show that what we have used those annotations and data set for so far to actually kind of give a perspective for the same. So we have built a smart prediction model and a phase prediction model using features, and we were able to achieve an F1 score of 0.8 and 0.71 respectively. Then we use the 2 models to extract the goals automatically from these conversations. And in that pipeline, we were able to achieve 68% goals where there were 8 out of 10 attributes correctly extracted. So out of those 10 attributes that we discussed for the smart tags, 8 were correctly extracted for 68% of goals. And then we also use Blue and Rouge to kind of provide evaluation metrics that is more standard. So for goal extraction example, this is an example. For example, if here's the conversation, the same as we saw previously, that stairs twice a week. We wanted to extract stairs between 6:45 to 7, Thursday and Tuesday. So that would be the goal summary, and that's what we wanted to extract. And now finally coming to the dataset 2. For dataset 2, we recruited 30 new patients, 3 different health coaches, and this time the study lasted for 8 weeks as compared to 4 weeks in the previous dataset. At the end of the study, we also recorded the feedback from the patients to see how they liked the study or not. Other than that, everything else was the same MyTab application and the Fitbits were given. We were able to collect 4,000 messages using this approximately, and this time patient had 42% messages as compared to 46 in the last time. So in this, we show the dataset 2 annotated using the models we built on dataset 1. So we show that smart prediction was able to achieve almost the same F1 score as on dataset 1, whereas face prediction did not do so well. The example here is also for the smart tags, where in the first one, both human and then the models predicted the same exact, whereas in the second one, the automated model missed any day among that, like among these annotations. The FN score for 0.81 is, in this we only changed, we switched the Google word embeddings to elbow word embeddings, and that's all. Using just the Google word embeddings, we were able to achieve 0.79. So in conclusion, we present 2 data sets that we collected between health coaches and the patients over text messages. We developed 2 annotation schemas for slot values and then the high-level conversation flow. Using these annotations, we built a goal extraction pipeline, which was able to extract 65% goals correctly almost. We show that the smart prediction model is able to reliably annotate the dataset 2 as well, even though it was collected with different patients and coaches. Finally, we will be building a dialogue track prediction model to improve the goal extraction and also experiment with the state-of-the-art pre-trained models such as BERT. Here are some of the references, and thank you for listening.
Hello.
Hello.
Hi, Casey.
Hey, Joe. How are you?
Hey, good to see everyone. Okay, I see
You too.
the authors. Hi there. Maxine, I think you're muted.
Yeah, Casey, I was just saying kudos. I don't know how you're doing this, but I greatly admire what you're doing. You're very courageous.
That brings a tear to my eye. Thank you. I appreciate that.
Yeah, I really like the Trello idea. I use Trello for my own development. I like
too, hence the choice.
Yeah, later recently we switched to the recent one that we did. I think Trello is pretty good, but recently more and more of my students like what is the other one? Forgot.
There's a bunch of them now.
Yeah. So we switched recently. Okay, let's see. There are more people. Okay, should we get started?
We have about 30 seconds, I think. As soon as it's 25 after the hour, then go ahead and it's all yours.
Cool. Okay, so welcome to the session for question answering for session 9, evaluation data. So we'll start with the first paper unsupervised evaluation of interactive dialogue with Dialog GPT from Shikop and Maxine. So both of the authors are here. So if you have a question, please press the button raise hand, and we'll go through with every single one of you. Okay, we'll start with the first, Adam Stiff.
Hi. So I guess I had a fairly simple question. I think it's really cool that you are using the model to predict the quality of the outputs by getting the probability of a positive sentence coming out of it. One question that I had was just if you think that sarcasm in the training set had a possibility of confounding that approach, or is that maybe not an issue?
I see. That's a really interesting question. That's not something I had thought about. I would just guess that if it did have an effect, it would have been minimal. But yeah, I guess like it would be really hard to actually evaluate something like that.
Understood. Sarcasm is always a difficult problem. Thanks.
Okay, we're going to the second question from Barbara Eugenio. Okay. Barbara, can you hear us? Okay. I think we can hear you.
Sometimes it's my headset. Can you hear me now?
Yes.
Okay. Thanks for the talk. I was curious, you mentioned 5 annotators at a certain point. You didn't specify anything. I assume if 5 Mechanical Turk, and then did you do intercoder agreement? Thanks.
Yeah, sorry. Just because of time constraints, I didn't have a chance to go into that too much. But it was 5 people on Mechanical Turk, and we computed the correlation between the annotators. And we generally got pretty good correlations. They range between 0.7 and 0.9.
Great. So we have another question for Nigel.
Yeah, really great paper. This is kind of a wacko question, so forgive me, but if you were going to do the same thing for evaluation of a spoken dialogue system, what would you do differently, and what would you expect to find different?
Well, okay. First of all, it's to do this effectively for a spoken dialogue system, we would need the equivalent of Dialog GPT trained on speech, which is a big challenge in itself. Yeah. I'm not too sure whether I'm qualified to speak as to what differences we might find, but I think that would be an interesting direction to go in.
Thanks.
Okay, we have another question from X Chen.
Hi, can you hear me?
Yes.
Hi, this is Chen Xi with Live Person. Are we allowed to ask just one question?
You can ask multiple questions. We still have.
Okay, cool. So actually, I'm very interested in the problem space, and I have like 4 questions. I had a chance to glance at the paper also. Some of them, here they are basically. So why is it that the whole is not the sum of the parts? So why? Because you have the turn level and the dialogue level metrics. So that's my first question. Can you just delve a little bit deeper into that? And second question has to do with the multifaceted nature of dialogue. So you used 18, I think, categories. Is it the more, the better? So that's my second question. And third question is the correlations results at the end. Is it good enough? Of course, if there, I mean, basically the question is that what future improvements can we get, and what are your plans for improvements? And the fourth is what is the rationale for your choosing a certain response, particular response for a category? For example, relevance. Why do you choose the particular sentences that you chose? Is there a rationale behind it, or just a trial and error? I can repeat my questions if you, yeah.
Okay, yeah, that's a lot of questions to remember, but they all seem really good. So your first question, why is the sum not, why is the whole not the sum of the parts? I'm like, the way I'm understanding that question is basically, why can't we compute the dialogue level qualities by just iterating over all of the turns and summing that up?
Yeah, and summing that up, we're doing, or average.
Yeah, I mean, like one obvious answer to that would be like different turns have different priorities. Like, especially for humans, you don't know whether, like, I think, like, personally, if I prioritize mistakes way more than I prioritize like good utterances when evaluating a dialogue. So like a mistake is way more likely to be emphasized and ruin my whole impression of the dialogue. So like this is one way that the whole is not just the sum of the parts. But I think like by separating out the dialogue level qualities, we just allow them to be treated differently, both by annotators and by the model. What was your second question again? Sorry.
The second question is it the more the better? Why are we using 18?
Yeah, well, for our analysis, we wanted more, just because we wanted to compare it to a bunch of different things. We wanted to collect a data set with a bunch of different things, but I think that that's not necessarily true. Ultimately, reducing the set would be a really good thing to do. And one way of reducing the set of qualities might be to like look at the fed data set and compute correlations between different qualities to come up with like an optimal set of qualities that captures the whole thing.
Potentially just using a subset.
Yes, because I think it's infeasible, like whenever you do human evaluation, to always do 18 different qualities, and trying to push that on people might turn them away from human evaluation entirely.
Yeah, I'm surprised your annotators actually didn't complain already. My third question is about improvements. Do you have any plan in mind for?
Right. Well, like, first of all, I don't think these results are good enough. I think that with an automatic metric, it's really hard to get good enough. But there's a couple of things that might make the performance better. Like, first of all, the correlations that are in the paper and that I presented in my presentation, these are for a single dialogue and for a single turn. When you want to, like, if you average that out over an entire system and you have like 100 dialogues for that system, the errors kind of decrease a bit. So this might be good enough to use just for somebody's purposes, but I think there's a lot of work left to be done. We have another paper at ACL next week that kind of approaches this problem a little bit differently for a slightly different setting. But I think a lot of people are actively working on this.
Sorry, I have to cut you at the moment. So because we have to make sure the other two papers also get enough time for the questions. But if we have extra time left in the end, we'll go back to the second question and more questions asked about the first paper. Okay. Let's start with the second paper's question and answer. So the second paper is towards a unified dialogue system evaluation, a comprehensive analysis of current evaluation protocols. So we have Sir and Jingho Cho from Emory. Let's see if you have a question, please raise your hand. So let's see, we can start with, so we do a little bit of diversity. So let's go with Diane first.
Hi, thanks for the really nice talk. I was intrigued by your really low inter-annotator agreement with the Alexa quality scores, and I was wondering if you thought about using, I don't know if they're still available, but like back in the communicator days, they had a lot of data, which I believe had some kind of overall score, and just as another test bed for your approach?
Yeah, that's a really good question. For like the sake of the paper we did this time, we wanted to use kind of a system that we knew very well because we had made it in the Alexa Prize. And so we could provide some justification behind maybe why certain qualities proposed like the certain interaction that we observed. But using another data set as a test bed is definitely a future direction for this work to kind of verify and observe the differences and like the similarities that you would see between different dialogue systems and dialogue strategies in terms of how like the human dimensions relate to the overall quality dimension as well.
Okay, thanks.
Okay, second question, let's go with Kenny Seiner. Oh, Kenny, I think you're muted.
So I really appreciated your talk. I thought it was very interesting the way you tried to summarize all the gazillion dimensions that people come up with. And one of the challenges that seems to me in doing that is making clear what some of these things actually mean. So I appreciated your trying to define them, but I wondered if you had any way to assess how well your annotators actually understood all of those various dimensions. The reason I ask this is an issue that's come up every time I've tried to do this, especially with words like engaging, one of my favorites, as a matter of fact. So that's one question.
Yeah, that's a good question. So for this paper in particular, I was the annotator that we did for kind of this preliminary study of how the different human dimensions that we identified were related to the other dimensions. And so because of my involvement in like kind of the paper as a whole and the actual like dimension reduction that we did, I feel like there was pretty good kind of intuitive understanding of what we were going for with the dimensions, but obviously a way to actually kind of more like solidify and define what the dimensions are and a way to measure how well the annotators were able to understand it is something that we would definitely need to do if like, obviously as we extend it out to less involved and more external annotator kind of strategy.
And the other question I have has to do with the notion of social chatbots as opposed to task-oriented dialogues. Diane mentioned the communicator dialogues, which are very task-oriented. And it struck me that the Alexa Prize is not simply chat because there's, tell me the weather kind of stuff, which is really task-oriented. So do you have a sense from, I haven't looked at those dialogues, of where they really are just kind of social companionship and where they really are occasionally getting at things that provide, for example, information, which is what Alexa can do?
Yeah, that's a really good question and something that we personally as a team, had to kind of make a distinction between when we were developing our chatbot for the competition, because obviously, like you said, there's a certain expectation that kind of the Alexa device already brings to people who know how to use it, that it's usually an information kind of oriented, almost like information, like almost like a question answering system in a lot of cases. And so it is very difficult to kind of make a distinction in the dialogues between what parts and even what dialogues as a whole that were collected from the Alexa Prize were kind of more information oriented versus more like chatbot and social and more experience oriented. For our personal chatbot that we made, we kind of made the decision very early on that we wanted to shy away from the information oriented direction because it had been covered so much already, and really explore what the capabilities and what struggles there would be for a more like experience oriented chatbot. And so for most of our dialogues, from what we could tell, they did kind of elicit more of the social atmosphere and less of the information requesting atmosphere, and that potentially mitigates that kind of struggle to determine what the actual dialogue content was for this type of a purpose.
Okay, well, we have one last question from Nigel.
Okay, yeah, thanks. Really great paper. Section 5.2, the expert didn't agree very well at all with the actual participants. which is very disturbing and worrying and depressing. So like a kappa of 0.22. I don't think other work has shown quite such dismal results. Do you have any thoughts on whether you did something differently, or should we really just give up on expert judgments and altogether?
That's a good question, and something that we were kind of surprised by as well, because like you said, a lot of works have seen better agreement between users and kind of more the expert annotators. I think there's kind of a number of reasons here, but I guess maybe I'll just focus on the two like main ones that we thought about the most. And the first one is that the setup of the Alexa Prize and the types of users that we're getting, and like the expectations that people have when they talk to the Alexa device are already kind of predefined and really explicit. And that potentially that type of an expectation really kind of shifted the distribution of what people were expecting from the like actual chatbot kind of atmosphere. And because of that, as somebody who was externally kind of annotating these conversations, where we were more coming from the more social oriented like expectation, we weren't able to kind of accurately judge what the users were going for and looking for in their conversations. And so our agreement kind of diverged on that like dimension. And then the second thing is that the setup of the kind of user interactive evaluation that we were using from the Alexa Prize and the expert evaluation were actually different. And that was kind of a limitation of what we did. The idea was that the users really at the end were only asked to give the overall quality, like their overall impression of the dialogue, whereas the expert annotation for this paper was the overall quality of the dialogue and these other like 7 dimensions, the relevancy, the grammaticality, all of these things. And when you focus on more than just kind of your overall satisfaction with the dialogue, and when you're asked to really kind of pinpoint these like your certain impression of these different explicit like categories, I do think it kind of primes you to be more critical. It primes you to find more issues with the system than you might have noticed otherwise if you weren't specifically like looking for those types of categories, because that was what we noticed, was that the expert annotator was more critical and more punishing on the dialogues than the actual users were. And so that might explain that a little bit.
Okay, thank you.
Yeah, I also concur that we have another paper in ACL also looking at the Amazon Alexa data. It's because the users are sort of a little bit random when they're scoring the conversations, because they were not specifically asked to do user study. So they're just interacting at home. Sometimes it's not a really great conversation and still get 5. Sometimes it's a good conversation and give it a 1. So it's still this kind of Alexa setting is different from the user study. Like you bring people to the lab, they're very cautious and rating them, giving you feedback. So there are differences between that too, for sure. Okay, let's move on to the third paper. Third paper is Human-Human Task Coaching by Text Messages, Corpus Annotation and Analysis, from Itaka Gupta, Barbara Eugenie, Brian Dibert, Aiswar Baiju, Bing Liu, Ben Garber, Lisa Sharp, Nadia Nabusi, and Mary Smart. So if you have questions, please raise your hand. Okay, we see the first question from Michael White.
Hi, Mike White from Ohio State and Facebook. Looks like really nice results in this paper, so I wanted to just ask a more general question. When you move to actually implementing your virtual health coach, I'm wondering what kind of changes you anticipate between the kind of human-human setup you have here. Will you need a multimodal setup to help keep track of like these things like steps? Or I was curious about, even establishing trust. How do you get the user to actually trust that the virtual health coach knows what it's talking about?
So, right now, so in the intermediate step, what we are looking at is where we can assist the health coaches right now. So like, that's what we're gonna do. So the application that we mentioned, like My Tab. So our next step is to like actually assist the health coaches and be like, okay, even if they like, do they even trust this automated system or not? So of course, like there is a lot of from their side as well, like we'll have to consider that. But I think one of the main things that we would have to think about if we completely automate as compared to what we have right now. So right now the text messages is like, oh, sometimes the patients won't respond for 2 days, or sometimes they would. So how do we deal with that in an actual dialogue system where the patients really doesn't respond immediately? So I think that would be one of the biggest challenges, and like how the turns are not really what we see in most of the dialogue systems, like how we have like a user system and user system. That's not exactly what I see in our data set, of course, because it's like text messages. So I think those would be two of the things, our main challenges that we would have to do, like deal with if it's like completely automated system, or do we just like make it in a sense that, oh, they do end up having the conversation at the same time, like complete conversation in this given moment and not like a text message system.
Okay, we have a second question from Candy. Okay, Candy, I think you're muted again.
Sorry, I mute things because it's noisy where I am. I really liked your talk, and I'm interested in the challenge you were trying to address of how to recognize different parts of the dialogue. The health coaching dialogues are very well structured, and it looks like your corpus is extremely well behaved. That is, people are kind of on point all the way through it. They don't misbehave and talk about something else. They don't get off topic, etc. And so I wondered how much you are in that domain able to use features of the domain that might not come up quite so nicely in other domains. The fact that there is, 7 different parts, and goal setting is what takes up 3/4 of most of the health coaching dialogues that I've ever seen, and I've seen a lot of them. So I wondered if you'd comment about that a little.
So like to rephrase the questions, like, oh, how do we deal with the out of domain conversation that might occur?
No, the fact that the conversation is very well structured and that there are no out of domain behaviors for the most part means that you should be able to predict a tremendous amount of the dialogue, especially because goal setting and follow-up really takes up 3/4 of every health coaching dialogue that exists. The barrier kinds of things negotiating are really pretty rare, and so you could do extremely well without even having to worry about those very much.
So I think like first of all, like the examples that I put in the slides are the ones which are more structured so that I can put them all together and show different parts of the, like, oh, there's negotiation and such. But we do have dialogues where they talk about different activities, like, oh, like I went dancing, or like about their dog, or they're going on vacation. And like when we did collect the data, it was like July 4th weekend. So they did talk about, oh, I have a vacation and then anniversary. So I didn't want to put them in here because like I wanted to show all those smart components and all the phases. And that's why I cut out those things. So we do see that a lot. And also given that they know it's a human health coach on the other side. So it's like very open, and they do talk about like whatever they like actually are feeling in the current moment. So they do also talk about sometimes their feelings and all. So we do, in fact, that's one of the challenges if we do like try to handle those, like how do we really do, like in the sense like when they are talking about, oh, how is your dog, or like they remember the name of their dog and such. So we do like we would assume that that's how maybe the health coaching dialogue would be if the patients knew that it's the system on the other side. But I think given they know it's a person, so we do see a lot of variation.
So Tim Bickmore's work shows that by introducing these extra dialogue things like, what did you think of the Red Sox, or how's your dog, and all that sort of thing, addresses trust. It causes people to trust the agent more. So obviously you're going to have to worry about those things. And, and the problem is if you just wait for the user to come up with them, people say anything and everything in the course of conversations. And so have you thought about what strategies you might undertake to be able to control the conversation so you get little trust conversations, if you will, but you don't end up dealing with the horrors of what humans will say?
So I think like it would be more of like kind of in the coaches, like to kind of instruct them, probably like when you're doing this data collection, that, oh, let's not deviate too much from the conversation. And I think that we did see like in the first round of data collection, it wasn't that much. I don't know if it's because of like the different health coaches as well. Like in the first one was a male as compared to we had 3 females in the next round. So probably that also affects like, because like those kind of like friendly conversation we saw more in the next round of data set as compared to the data set one. So I think if you want to limit that, so we probably would be instructing the coaches to not deviate too much from the, like if you want to limit those. But if it's actually we want them to have real conversation of human-human, then, I mean, we didn't really instruct them on anything about it, like, oh, please limit or this. We really wanted to collect the actual human-human conversation to actually see what goes on in health coaching. And then, of course, when we move to the automated part, we cannot really have everything like what human-human conversation has. So we probably choose the few which actually give them the trust, but we cannot really have everything about, for example, when they talk about their feelings, how they're not feeling too well, and like they really go into deep about some of those issues. So we can't probably handle those in the automated environment.
Can I just add one thing, that this is also through text messages. So that constrains somewhat the, how expressive people are, and the virtual coach would also, or assistant coach to the coach, to the human coach, would also be via text messages, because it's embedded in this application that through which we are having these exchanges.
Okay, great. Thanks, everyone. So the session is officially time up, but we can still stay to ask questions even for the previous 2 papers. If you still have questions for the papers, please raise your hand. We'll still coordinate you to get through every question. Okay, so Barbara, you have a question? Oh, I think Barbara, you are muted. Okay.
Yeah. Sorry if I keep, it's for the second paper. Sorry if I keep the authors here and the others. So I was really curious about that point you showed about, when you try to reconcile the various definitions of grammaticality, and I'm not really sure that fluency and grammaticality are the same thing, even if the authors were using that, because fluency is also much more contextual, right? It could be, I could say, with him, I went to the park. That out of context doesn't sound that fluent, but in the appropriate context does. So I think, I mean, without having read those papers, right? But it seemed to me that that maybe the usage of fluency is not really a good proxy for grammaticality. So I thought, I was wondering if you had any thoughts about that.
So that's a good point, of course. And obviously this work is not like, the point of our work was not necessarily to propose like these are the final dimensions that everybody should use when they do human evaluation for chat-oriented dialogue systems. So obviously what we had found was that within the 20 papers that we had looked at, when people used fluency, they did kind of mean for it to mean grammaticality, but obviously that's not the only definition of fluency that there is. And like what you're saying, there is kind of this second, if not equal definition of fluency that definitely should be included as a human dialogue dimension. But yeah, like I said, we didn't want this to necessarily be like a final set. It's more like a step into seeing what the most common ones were that people had used recently. But that's a really good point.
Thank you.
Okay, we have a hand from David Trump.
Yeah, I guess this is mainly for Shakib and Maxine, but so this is a very interesting idea. I'd like to see more diverse set of evaluations, or comparative, where we have some human evaluations against them. And I wonder if you could speculate based on what you've done so far of how hackable this metric is. So once people are using Dialogue GPT as part of their decision-making process, does that blow this evaluation out of the water because it's, you know, and all the correlations are lost, or is it something that maybe would still have some applicability, or there's some way to get around that?
Right. I guess like one thing that is very conceivable is that somebody just takes dialogue GPT, it takes like our Fed metric and then trains a generative model and then uses like this, uses the Fed metric as a reward. But like that type of thing is possible with any automatic metric, and that's a risk with any automatic metric. And I guess there's sort of two issues that need to be addressed there. Like, first of all, if somebody does do something like that, will it necessarily end up in better dialogue, or will it just end up in dialogue that better games the metric? And I think that I'm hoping that because like of this indirect property of the Fed metric, where you're looking at the next user utterance, it's going to be more of the former and less of the latter. But then the other thing that I should mention here is that by no means are we proposing this as an alternative to human evaluation. Like, we're saying that you definitely should do human evaluation as the final step, but this is more of a tool for the system developer, just so that they get a sense during the development of their dialogue system, how good is it actually doing? What set of hyperparameters should I use? And therefore, it's not in their best interest to try to game the metric, because when they do human evaluation in the end, they'll be like they're gonna get way worse results. And I think like it's, the other thing I should say is that it's harder to accidentally game the Fed metric just because of its indirect nature than it would be to game something like Blue Score.
Yeah, that's really interesting. I have a follow-up question since it's offline time. I really like the idea, but one of the question would be the model that you're using Dialogue GPT to fine-tune, right? What if we change it into even sort of more a bigger model, which has better quality, like a blender? Would that actually preserve the correlation, or that actually improve the correlation? Because it's really hard to see or explain what these kind of pre-training model really captures. It definitely has certain some like your coherencies or whatever that it was trying to calculate, but we don't really know what it is actually doing. But I do like the idea a lot in terms of it's really about the user's reflection to the context that matters in terms of the evaluation.
Right, yeah, that's an interesting point. I think that the way we view Dialogue GPT here is as a proxy for the user. So given that it should be reasonable to replace it with any other model that is like reaching human level response generation capabilities and expect the same result. And what we actually did in our paper was we didn't look at one version of the Dialogue GPT model, but we looked at 4 different ones. And what we generally saw was that for most of the qualities, if one model was highly correlated, the bigger model was also correlated, and like a model with different hyperparameters was also correlated. So like, I think that like, obviously they're all still Dialogue GPT, so maybe a model that's trained entirely differently would correlate differently, but like it shows that this strategy of using the follow-up utterance is something that holds across different models, as long as those models are effective proxies for humans.
You're right. Yeah, I guess that totally makes sense. But definitely, what in terms of like the data that you pre-trained it would have a big impact on the performance. And also, for example, the pre-training data, does it include or have similar utterances that you use as a test utterance, right? Wow, it's so interesting.
Well, yeah, that's something that we thought about a lot, because like I think that on Reddit it's actually really rare for somebody to say like that's a very relevant response. But still, when we do this with our model, with our Dialogue GPT model, it ends up working well. And I think this is like this is sort of hinting at this notion that Dialogue GPT has captured some like compositional understanding of language, and that it's able to like generate language that it hasn't necessarily seen before in its training set.
Wouldn't you expect that you would see things like that in Reddit, that people would refer to whether this is, you know, a on topic and substantive and maybe slightly unexpected. That was what I would think for seeing something in a blog post, something like that in a blog post. But it might, I don't know that how well I think it would correlate with, you know, what would actually show up in a like a dyadic conversation.
Right. I guess like an example that highlights my point a bit better would be like, that's not fluent, or like something like that. Like you can definitely imagine some of our qualities. It's unlikely that somebody's ever going to say, I like your personality, for example.
It's possible.
Maybe, yeah.
Yeah. Okay, cool. Let's go to the next question. Chan.
Yes, hi. So I think my question has been partly answered, that which regards how do you choose the particular responses to get the probability for, and apparently it doesn't come from the fine-tuned set, or it's just something that you make up on your own.
Yes. Yes. So
Okay.
so I think like to elaborate on that point a bit, we like made sure that, or what we were kind of going for was that the follow-up utterances, as long as they were semantically close to what the quality actually means, shouldn't really matter too much. So like we don't want to spend too much time getting the exact wording of follow-up utterances that will end up in these correlations. So like we didn't tune it too much at all. Like we just took a small set of dialogues, chose like we wrote a couple of follow-up utterances, tuned it a bit to basically just add more or capture a wider set of responses, and then that's it. So like we didn't like try to get the exact right set of follow-up utterances, because I think that kind of defeats the purpose of this whole thing.
Okay, when you say you tune it, do you tune it like you are passing a partial conversation and then the response is this is relevant?
No,
like
when
that?
I say we tuned it, what I just mean is we manually wrote more or less utterances depending on how it did on a small subset of the data set.
Okay. Cool. Yeah. Thank you. And we may reach out. I mean, if you're available for further collaboration.
Sure.
Thank you.
Okay, so we go to the next question. Ifra, Idris.
Hello. I actually have a question from the second paper, which is like human to human health coaching one. So I actually wanted to ask about your data collection method. For example, in case of health, the adult can ask about like various things. It can be about their blood pressure, about their exercise. So when you were doing data collection, did you give cues to the participants about what were the sort of subtopics they could talk about, and how much deviation was there while you were collecting the dialogue from like the main topic, and how did you do the annotation? So yeah, and great talk. Thank you.
Thank you. So we did not give them, like initially we did tell them that this is about physical activity. So like the coaching will be about physical activity. So they knew that it would be about them setting goals for like how many steps they're going to do and such. So that was the idea. And like what that we explained them, oh, this is how we'll be asking you to set the goals, like smart setting goal approach. But like during the conversations, yes, there was deviation, not particularly more like medical or something. There was just like a few instances where people probably talked about like they're not feeling well, or like their ankle is hurting or something, probably from doing more activity or such. So we did not restrict them at all about like what they can talk about. But of course, like they were told that, oh, this is the intervention is about physical activity, and like the data collection is for that.
Can you like not have an exact number, but sort of like quantify how many, like, or even in a single conversation, how many times did this deviation happen or something like that?
So it depends upon like what the deviation would be like. So some of them are like not that much. So for example, some of them would be about they went dancing and that's why they have these many steps and all. So it's not really deviation, it's a kind of a reason. And some of them would be more of like, oh, I'm going for a vacation because it's a July 4th weekend. And then, so I'll probably have more steps, or I might not have those my steps. So there would be about like once or twice in one conversation. Some, and then of course it also depends upon a person to person. Some of them are more willing to talk about different things. Some of them are really to the point. This is my goal, that's it, don't text me apart from that. So so it's, but yeah, like the deviation are not as like we did try to think that if we do need to handle the cases where they're like emergency cases where we do have, but they were not that many, like the emergency cases. Right?
Thank you so much.
Great. Do we have any questions left? Okay.
I have just a comment for Itika and Barbara and the rest of the authors. It's a really good paper, and I think it can, the SMART goals can be used in different domains, like in the workplace, for students as well, to set up their goals for learning goals. So I think it has a lot of potential. And also, yeah, the challenge is going to be to build this trust, and when there's the real, like a chatbot or either the health coach assisted with the chatbot itself. And if it's the chatbot, whether you tell since the beginning that this is an AI behind, and yeah, I think that it's a very interesting work, and congratulations.
Yeah, I just also want to add in terms of the trust. So I also have a collaboration with UCSF nursing school on similar like a goal settings, like a persuasion for we're mostly targeting to type 2 diabetes patients to increase its exercise level. So one of the things that we thought about is, first of all, it's about the framing of the chatbot. You could say this was developed by nursing school from UCSF, right? So having this framing usually increases the trust. And of course, like our social interactions matters, like a self-disclosure usually is considered in human-human conversation, the way to build trust in a relationship. So social conversation definitely would matter. And because it's exercise coach, right? You're interacting with it longitudinally. You're repeatedly interacting with the system. So over time, you can increase the level of your self-disclosure in order to build trust and warmth over time. So yeah, it's a very interesting area. And I think chatbots, dialogue system in health domain has a huge impact, but we're still really getting into it because of a lot of this kind of a risk aversion of the medical areas and so on. But I think it's definitely an area with a lot of potential.
Can I make one final comment? That in fact, we have presented and analyzed the data we collected, but before they started the intervention, at least in both data sets, right, Itika, they met the health coach in person, and they were explained what the purpose is and why we're doing this, and all those things that you tell your subjects before you start the study. In the first round, we didn't collect that data. In the second round, we collected at least some. Itika, you can give the details. So there is that. So that, of course, sets with respect to the trust, that already sets that interaction, on a solid foundation, let's say.
Yeah, for sure. That would be great. So you brief the users, and that definitely establishes certain trust. Great.
Yeah, they were explained like what the study and everything is, and then a lot of the conversation about their goal setting was actually happening in the first interaction, and we did not record that in the first time, but then we realized, oh, they are actually interacting a lot about their goal and everything. So we kind of made the health coaches take notes about those, like why did they decide upon certain goal, and there was usually a reason behind it.
Great. Thank you everyone for participating. So we have all other sessions coming up. There are discussions in the afternoon as well. Thank you. Bye.
Thank you.
Yes, thank you, Joe, and thank you all the authors and everyone for your participation.
Thanks, Casey, for all the hard work in putting this together in such a short amount of time.
Well, I've got something I would like to share my show the board yet again to explain a few things. Well, first thing is we added a couple of cards. One that I would like you to see is general discussion. This one is really, you can talk about anything here. but for example, Luciana Benotti has something about being a volunteer for the ACL microblogging, and she wants to blog about anyone in the SIGDIAL community who has a paper accepted to ACL. So please visit that card and have a look, and then you can maybe send her some information. Her email is here.
Yes.
Another thing to consider, well, I want to discuss scheduling now. The next thing that's going to happen is session 10, demo 3. That is going to take place in just about 20 minutes. That gives you enough time to watch both of these videos before the live interactive meetings. In fact, I'm going to do you a favor and keep this live stream going and just play them back during the break. So you can be watching those, and then in about 20 minutes, 30 past, there are two meetings that will happen with the authors of those demo papers. And then that goes from there into a break, and then into the breakout discussion topics. There are 8 of them that will happen following the demo. And those will start in roughly an hour. So there's several topics the first hour, several topics the second hour, and several topics the third hour. I encourage you to look at those. I do want to show you that if you aren't decided which one you would like to join and the participants might sway your vote, you can look at the voters, but if you can't see their names, you can hover over them and that shows their names. Just so you know that functionality is available to you to help you decide. And then, but after this little, after this Q&A and this little thing that I'm doing right now, we're gonna show the 2 demo papers, and then that's it for the live stream until, for about 5 hours, until we start session 11 in about 5 hours after the breakout discussion topics. So the breakout discussion topics and the demo paper interactive meetings are not going to be live streamed. So continue to participate with the demos, with the live breakout sessions, and we'll start the live stream again in about 5 hours. But for now, we'll start playing the 2 demo presentations, and then that will be it for now. So those of you who are still in this meeting,
Welcome to our demo on agent-based dynamic collaboration support in a smart office space. Since 2007, we've been developing dialogue agents that can serve as facilitators for collaborative learning between multiple students. And most of the studies that we have run have been in online chat spaces. And these studies have shown that these conversational agents are highly effective at increasing student learning gains by drawing out student reasoning and encouraging students to build on each other's reasoning. The architecture works through a pairing between what we call listeners and actors. The listeners are filters that look for opportunities for the conversational agents to intervene. And the actors are dialogue agents that come in to achieve a particular end over a short period of time within the extended interaction. And over the years, we've developed a number of design principles for these conversational agents that have been validated in empirical studies and published in multiple venues. Most recently, we've been working on supporting collaborative programming, and we've already run a number of classroom studies with an online version and support for group learning using an industry paradigm of mob programming. In today's demo, what you will see is how we've taken this online chat-based technology and brought it into the 3D world through multimodal technologies. In the 3 scenarios that you will see, we will only have 2 students working together in the room for social distancing.
In the first scenario, when users enter the room, the virtual agent notices them, assigns internal identifiers to distinguish them, and tracks their locations.
If the users identify themselves, their names will be associated with their internal identifiers, and thereafter the virtual agent will use their names. Next, the virtual agent introduces the activity.
Wow, is this the room?
I think so. Wow, nice room. What's it?
Welcome. We'll be starting shortly.
Wow, she looks cool.
Yeah.
What's her name?
Nice to see you. I'm Agent Rachel. Please take a moment to introduce yourselves.
Hello, I am Joe.
Howdy, Joe.
Hi, I am Eric.
Howdy, Eric.
Today we'll practice pair programming as you collaborate on the diamond kata exercise. We'll use test-driven development. For the first test case, why don't you start as the driver, Eric?
Okay.
Joe, why don't you start as the navigator?
Sure.
When you've reached your seats, you can start on the first test case.
In this activity, milestones are accomplished each time the programmers pass another test case.
The agent can plan to stimulate academically productive talk for events that it can foresee, and it listens for dynamic opportunities to enrich the discussion. Okay, so maybe we need to first discuss the problem, right?
Yes, maybe we can use the whiteboard to discuss. So, what we need to discuss first?
Maybe we need to know the relationship between the input and output, right?
Okay, let's figure it out. If the input is C, what's the output?
A, B, C, B, A. It should be 5 lines.
Okay, it's 5. So let's try D.
D.
Yes, maybe it's... Oh, we need to add 2 more lines into it, right?
Yeah, so it should be 7 lines.
Okay, good.
So what's the conclusion?
I don't know. Let's code it.
Okay.
In the future, please be very careful about social distancing.
To test, try the first test case.
Okay, let's try. Did it pass?
You passed a test case for the number of lines your program will output. Do you need to know the number of output lines?
What do you think about it?
I'm not sure, but I think we need to figure out how many lines do we need.
Yes, otherwise we won't know the format of the output, right?
Yes, it's a diamond, so...
Yeah, so we are pretty sure about that we need the number of lines to output.
Yes, I'm also pretty sure.
Would you like to discuss this algorithm choice?
Yes.
Yes.
Have you thought about a recursive solution? How would you use the number of lines to output? It sounds like you could use some help.
What kind of help?
Another way to control iteration would be to use the order of the alphabet. Would you still need to calculate the number of lines to output?
Yes, you are right. We don't necessarily need it.
No, we don't need that.
Yeah.
So, what's the next step?
When it's time to work on passing the next test case, the programmers switch roles. The agent constantly monitors the users for salient information, including changes in location.
During this time of social distancing, the agent checks whether the users maintain a distance of at least 6 feet apart.
It's time to switch the driver and navigator roles.
Okay, so how to do that? What do we
Why
need to
don't
do?
you be the driver, Joe?
Sure.
Eric, you will be the navigator.
Okay. Let's start.
Yeah. Okay, you can.
Oh, yes, sure.
In the future,
Oh,
please
sorry.
be more careful
Sorry.
about social distancing.
So we can start review?
Yeah.
Okay, let's start.
Thank you for joining our demo. Please come to the TEAL website to find out more about the work that we're doing. And you can contact us at teal@andrew.cmu.edu.
Hello, my name is James Finch. I'm a PhD student advised by Gino Choi at Emory University's NLP Lab. And today I'm going to be presenting our new dialogue development framework, EMRA STDM. So anyone who has worked on developing a dialogue system knows that it's a ton of work. Of course, in research, we like to focus on trying to train conversation models from data, but often the reality is that you have certain specifications for your system that just aren't represented well by any data set. So in these cases, handcrafting, or at least defining certain constraints for your system's behavior, is inevitable. The purpose of dialogue development frameworks is to streamline the process of creating a dialogue agent, especially when handcrafting starts to get involved. So a lot of frameworks are already out there, but we believe none balance ease of use with customizability quite as well as what I'll present today. So for example, there's a lot of commercially oriented frameworks like Google Dialogflow. These are really easy to use, but they do sacrifice customizability. The academic community has also produced a class of frameworks that are driven by update rules that follow the information state theory of dialogue management. So these support complex interactions, but they can be cumbersome when you're just creating a simple system or doing rapid prototyping. Finally, there are some frameworks that are actually languages, like AIML or ChatScript, but these tend to focus on modeling user initiative conversations with pattern matching, which is just inherently limited. So we present EMRA State Transition Dialogue Manager, or EMRA STDM, which is a Python package and framework for dialogue system development. Our goal is to maximize speed and intuitiveness without sacrificing any customizability for expert developers or researchers. And EMRA STDM achieves this by seamlessly integrating pattern matching, trained models, and custom logic. It also supports 2 fully interoperable dialogue management approaches. One is based on state machines for rapid development, and the other is based on information state theory for modeling complex interactions. So getting a dialogue agent up and running in EMRA STDM can be done very quickly, just by defining a state machine to drive dialogue management. The dialogue context is efficiently modeled as a state in the state machine, and transitions alternate between representing user intents and then system responses. Defining the structure in the state machine using code is done with a very easy to use JSON syntax. And this syntax reflects the hierarchical nature of conversation pretty elegantly. Now, distinguishing which transition to take during the user turn especially is done using our novel natural language understanding mechanism, which we call the natural language expression, or natex. So natex is an extension of regular expression. It has a custom syntax specifically geared towards pattern matching for natural language. It functions by compiling into a regular expression, so it supports all the features of standard regex, but unlike standard regex, natex allows developers to embed function calls to arbitrary logic within their pattern matching expressions. So this allows seamless integration of quick-to-develop pattern matching with database queries, trained neural models, or any other custom logic that you might need. So for an example, consider this natex, which attempts to capture the user expressing that they like a certain activity. And the $ notation there is representing that it's also trying to save whatever activity was matched into a variable called x. So we would like, what we would like to happen is for the third term of this pattern matching expression to basically run a part of speech tagging model and match any token from the user input that's a verb. So when the user is when the natex is matched against a user input string, the function call term will call a custom function during the compilation of the natex into a regular expression. So these natex functions are easy to define, such as this one that finds all the verbs in the user input using a part of speech tagger. This function returns a set of matching tokens, which are then embedded back into the natex to continue pattern matching. So this formulation allows simple pattern matching to be easily extended by powerful logic whenever you need it. An additional feature of our natex formulation is that it can be used for natural language generation as well. So a natex can generate variant system responses by essentially randomly selecting an element from each disjunction clause. This allows developers to easily create variety in system responses, as well as taking advantage of natex's ability to set variables or call custom functions for even more sophisticated generation. So by defining a state machine where each transition is modeled using a natex, a high volume of simple interactions are easy to develop and then extend to be more complex. Since any variables set by a natex during a transition persist throughout the conversation, interactions can be parameterized, and they can also recall previously learned information, which can give the user a true feeling of understanding. Okay, so while great for rapid development, using a state machine alone for modeling dialogue is notoriously rigid. And so for this reason, Emera STDM additionally supports a dialogue management mechanism based on information state theory, where a set of update rules is allowed to arbitrarily modify the dialogue state and response. So each update rule is formulated as a conditional if-then statement, where the precondition is a natex that is matched against the user input on a specific turn. And the postcondition is a natex that running under the NLG compiler. Each turn before the state machine is updated, all update rules that can apply are triggered, which essentially allows more complex reasoning and conceptual abstraction of the user input. So as an example, suppose that the user mentions their wife during a conversation, and what we want our system to be able to do is reason that the user is an adult if they ever mention a spouse. So an update rule pattern matching for the expression my wife or my husband could be triggered, and then the postcondition could set a flag indicating the user's marital status. Now, more than one update rule can trigger on any given turn. So once the marital status variable is set, this could in turn trigger a second update rule, which infers that if a user is married, then they're an adult. We could even want our system to directly output a response based on this information using an update rule. So for this example, we have a third rule checking if the user is an adult, and then this rule's postcondition contains a natural language response for the system, as well as a priority score. So when an update rule postcondition contains a priority score like this, it indicates that the natural language generated by the postcondition is a candidate for the final system response. In this way, candidate system responses are collected both from the update rules as well as from the state machine system transitions. The candidate response with the highest priority is selected as the true system output, and by default, just all priority scores are 1. So in this case, the priority is 2, and so it would likely be the true response. In general, interactions based on update rules are more complex and they might require more expertise, but they allow for abstract reasoning and globally applicable responses and transitions. As a whole, the state machine and update rule mechanisms in Emera STDM complement each other. So of course you could develop an entire dialogue system just using one mechanism, but they each have different strengths. So Defining transitions in the state machine can be done very quickly to build a foundation for the system's primary interactions, but then it can be supplemented by update rules to reason about learned information. At Emory NLP, our team certainly found Emera STDM to alleviate a lot of headaches that are typical when developing a large-scale dialogue agent, and we hope others can benefit from its public release. Thank you for watching.